Hi friends, this video is brought to you by Physics Hunters. Hunt your physics related content in Physics Hunters. Knowledge is power. Power is rate of doing work. Work more, gain more. So here we start off with the chapter electricity from class 10. Now before starting with the chapter, let me motivate you that who discovered electricity? Who discovered electricity? It is Benjamin Franklin who discovered electricity when he was doing the kite experiment. Accidentally, he found the concept of electricity. And what is electricity? So what is electricity regarding with? Let me ask many questions. Who discovered electricity? It is Benjamin Franklin. What is electricity? Somebody say it is energy, somebody say it is a study. Of course, energy is nothing but electrical energy that we talk about. And when I talk about what is electricity, we can say it is an energy. But generally, if I say what is electricity, you have to think about the study of charges and current. And why we have to know about electricity? Because we face electrical challenges, electrical demand, electric current demand here. So we need to know how electricity, what is electricity. So it is a technology now we face in electricity. So we have to know why we have to know about this electricity. We have to ask the question. And how electricity is produced? You could have heard about the windmill production using the solar power production or hydroelectric power production. There are n number of sources that we have to produce electricity. And you imagine that what happens if electricity is not there, right? It is very difficult to lead a life nowadays without the electricity. So we know now the importance of electricity. Now if I say what is electricity, it is nothing but generally according to the statement, it is nothing but it is a study of phenomenon of electrical charges and current. Study of phenomenon of electrical charges and current. So regarding the charges we have to know, and regarding the current we have to know. So that is about the electricity. And if I talk about first basically electrical charge, what is called as electrical charge? Of course, you know it is a fundamental property of a matter. Electrical charge is represented by Q and it is a fundamental property of a matter. And this arises from the concept that in any atom there are proton, neutron inside the nucleus, and electrons will be revolving around the nucleus. And there will be some electrons in the outermost shell which are said to be called as a free electrons, which are ready to move. That moving electrons will constitute the current. So that electron, free electron, which we talk it as a charge. So either the electron will be referred as a negative charge and proton will be referred as a positive charge. So this is the basic idea of a charge which is symbolized by Q. And it is a fundamental property of a matter. And the unit of electrical charge is expressed by Coulomb. The symbol of unit is C. And of course electrons have a negative charge of 1.6 into 10 power minus 19 Coulomb. Charge of a single electron is 1.6 into 10 power minus 19 Coulomb. Whereas protons also have an equal charge. The same thing, 1.6 into 10 power minus 19 Coulomb. But they are positive. So that is a basic detail about the charge. And if I want to ask a question like, how many number of electrons are there in 1 Coulomb of charge? So I can say that number of electrons in 1 Coulomb of charge, right? So I have to know about one, that is charge of a single electron. Charge of an electron is nothing but, as I said, 1.6 into 10 power minus 19 Coulomb. And if I want to know number of electrons in 1 Coulomb of charge, I have to take this way. Let us consider that let the number of electron be 1. For a single electron, what is the thing? That is here for single electron, as I said, the charge is 1.6 into 10 power minus 19 Coulomb is equal to 1. And so what is 1 Coulomb? 1 divided by 1.6 into 10 power minus 19, which is nothing but 1 Coulomb is equal to 6.25 into 10 power 18 electrons. So how many number of electrons are there in 1 Coulomb of charge? It is 6.25 into 10 power 18 electrons. And if I talk about if 2 coulomb of charge, if I consider this value multiply by 2, which is 12.5 into 10 power 18 electrons. So how many number of electrons are there in 1 coulomb of charge? It is 6.25 into 10 power 18. And if it is 2 coulomb of charge, it is 12.5 into 10 power 18. Regarding the properties of charge, if I talk about the properties of electric charge, we have certain properties to be remembered here. First of all, the first one I can say that the charge is conservative. That is, it is constant. So, the charge is conservative. And the second one I say the charge can be additive. That means so if any kind of a system is there and there are n number of charges, say Q1, Q2, Q3 and so on. So the net charge can be obtained by adding the individual charges Q1, Q2 and so on. Right? So this is kind of an additive property. And third one is quantization property. We have to talk about quantization property. So quantization is nothing but, we can explain this quantization, that quantization is nothing but the charge can be expressed as a integral multiple of electron or a charge, right? That means total Q, which is nothing but integral multiple of an electron, an integer multiplied by the charge of an electron. This is called as quantization. So this is a basic idea about the charge, right? So we know now about some idea about charge, where it comes from. Now we have to talk about the current, right? So what is electrical current? As I told you, the free electrons that are in the outermost shell, these free electrons ready to move, and these moving charges constitute the current. And for the charges to move, there are certain conditions to be essential. There are some essential conditions. What are those essential conditions? The essential conditions are, first one, excess of electrons. Number 2, presence of closed conducting path. Excess of electron means I am talking about a free electron. And the second one is presence of closed conducting path, which is nothing but an electrical circuit. And the third one is some kind of energy, source of energy that sets the motion of charges across the conductors. So some kind of a driven force has to be given to make the charges to move. So these are the essential conditions for the charges to move. That means for the current to flow, the three essential conditions are excess of electron, electrical circuit and some kind of energy to be set. So this is about the basic conditions of the electrical current. And what is electrical current? Electrical current is nothing but the rate of flow of charge. If I want to discuss what is electrical current, which is symbolized by the letter I, right? Which is symbolized by the letter I can say that the electrical current now, it is indicated by the letter I, which can be defined as the rate of flow of charge, which is called as current. So I can say I is equal to T. T is nothing but time taken. I is equal to Q divided by T. Of course, the electrical current is a scalar quantity and the symbol is I, right? And Q is a charge and T is a time. And if I say I is equal to Q by T, Q is represented in coulomb and time is second. So coulomb per second is the actual unit of current, which is then renamed as ampere. So what is the unit of current? It is ampere. So what is 1 ampere? It is 1 coulomb per 1 second. That is called as unit of electrical current. And now I said that we know about now charge, current and how many number of electrons are there in 1 coulomb of charge, say 6.25 in 10 power 18, everything. How to measure the current? The instrument to measure the current is ammeter. The laboratory like ammeter, it is nothing but looks like this one. Say it is terminal like which has to be connected over there. So here the instrument to measure the current is called as ammeter. It is called as ammeter. Ammeter is an instrument to measure the current. And we have to know the conversions right here. Say 1 microampere, right? 1 microampere, which is equivalent to 10 power minus 6 ampere, and 1 milliampere, which is equivalent to 10 power minus 3 ampere. So these basic ideas also we need to know about. So we know now charge and what is current, right? And how to measure the current. And we have to know about the direction of a current. Of course, it is a scalar quantity. The current is a scalar quantity. Though it is a scalar quantity, we don't bother about in which direction it flows, because basically before the invention of the concept of electricity, it was said that the electric current is nothing but it is due to the flow of electron. But from the circuit, it is designed in such a way, from the positive terminal only the current flows. Suppose this is your positive terminal and this is your negative terminal. Here you go with like all the electrons will flow here, but we are setting the current in this direction. The current is flowing in this direction. So this type of a direction in which it is opposite to the direction of electron. Opposite to the direction of electron, we call it as conventional current. Why it is called as conventional current? Because the direction of the current is opposite to the direction of electron. It is called as conventional current. So this is called as conventional current. This is, though we don't bother about it, you know that it does not bother about the direction of electron in which it flows. Though it is very difficult to admit it, we can just have a satisfaction to have an expression, say I is equal to Q by T. You know that charge is negative. Electron is having a negative charge. So I can say it is minus Q. If I say minus Q, the Q, I and minus Q in this equation, if you say I and Q are equal but opposite in direction, right? This I is this Q is nothing but it is about the electron. So if the electron is flowing in this direction, as per this equation which is having a negative sign, it shows that the current will be in the opposite direction. So we have certain the concept to make out the concept of conventional current. And now we have some symbols to be remembered here. How the electrical single cell is there, one positive terminal and one negative terminal. A battery or the combination of cells means combination of more than one cell, we call it as a battery. And you can see a plug key, right? That is a switch open it is, and plug key which closed key, that is with the switch it is, and a wire, joint wire and wires without joint, and you can be able to see the electrical bulb can be symbolized in both the ways. And this is one of the important thing, a resistor, it can be symbolized, and the variable resistance, that means the resistance can be varied in a circuit, can be done by the arrow mark, or this one is called as an instrument rheostat. That means the instrument used to vary the resistance. And this one ammeter, and this one is voltmeter to measure the voltage, and G is the galvanometer. All these things we will be discussing in the next class.